Welcome to the introduction to trigonometry. Trigonometry is the branch of mathematics which deals with the measurement of sides and angles of triangles and their relationship with each other. I'll repeat. Trigonometry deals with triangles, and what we're interested in is the measurement of sides and angles and how these sides and angles are related with each other. A right-angled triangle forms the basis of all trigonometry. In a right-angled triangle, we refer to the sides according to how they are placed in relation to the angle theta. Here's a right-angled triangle, and consider the angle theta on the right-hand here. The side opposite to the angle theta is called the opposite side of a right-angled triangle. The side adjacent to the angle theta is called the adjacent. And the longest side of a right-angled triangle is called the hypotenuse. All the basic trig identities are derived from the right-angled triangle. The first one which we will consider is the sine of theta, abbreviated as sin theta. And the sine of theta is a ratio of the opposite divided by the hypotenuse. So in a right-angled triangle, if we take the length of the opposite and divide it by the length of the hypotenuse, we get a trig ratio which we call the sine of theta. Now, what exactly is sine theta? Where does it come from? The word sine was borrowed from the Latin noun sinus, which means a curve. Consider the diagram. On this diagram, we have a red curve, which is the sine, according to the Latin word noun sinus. So the curve is the sine, and this sine has a scale of 1 to -1. Also on this diagram is a circle. Notice the axis. We've got the x-axis there, the y-axis, the negative axis, x-axis, and the negative y-axis. And within this circle is a right-angled triangle, and within the right-angled triangle is angle theta, and the angle theta is opposite to the green side, so this is the opposite, and it is adjacent to the blue side, so this is the adjacent, and the longest side of this triangle is of course the hypotenuse. Notice that there is a relationship between the opposite side and the value of the sine curve. For instance, in this particular case, the value of the sine according to this scale is around 0.75, and the length of the opposite is also 0.75, which means there is a relationship between the length of the opposite side of a right-angled triangle and the value of the sine. This relationship is perfectly demonstrated here. Watch. Notice the value of the opposite side, or the length of the opposite side, is equal to the value of the sine curve. Watch again. This length is almost 0.5, and the value of the curve is also somewhere around 0.5 according to this scale. Watch again. The length of the opposite side here is almost equal to 1, and the value of the sine curve is also almost equal to 1. Watch again, please. This time, the length of the opposite side is negative because it's on the negative side of the x-axis. The negative side of the y-axis, I'm sorry. And the value of the sine curve is also negative. The sine curve is being generated by the length of the opposite side as the radii rotates 360 degrees about the center. Watch. Let's now conclude why the sine at theta is equal to the opposite over the hypotenuse, or the curve at theta is equal to the opposite over the hypotenuse. So here we've got a curve which we have called the sine, and we are saying that at the angle theta, notice the angles here, we've got 0 degrees at that point, 90 degrees, which is the highest point there, 180 degrees, and so on and so forth. I also want you to pay attention now that the radius of the circle is equal to 1. And within this circle, we've got a right angled triangle which has got an angle theta there. We also have the length of the opposite, which is equal to 0.75. And also on the curve, we have got many values which are 0.75 on a curve. But I want you to pay particular attention to one point on a curve. At this point on the curve, the value is equal to 0.75. The value of the sine, the value of the curve, is 0.75. So we are saying that the curve at the angle theta is giving us 0.75. Using a calculator, we can calculate that the sine, the angle, is actually equal to 48.6. Now notice that angle between 0 and 90 degrees, 48.6, looks very realistic. So we are saying that the value of the curve, if the curve has got a value of 0.75, then the angle is 48.6. Let's wrap it up. We said the curve at theta is equal to the opposite over the hypotenuse. The opposite is 0.75 and the hypotenuse is 1. So we're going to have 0.75 divided by 1, which is equal to 0.75. This curve at this angle has a value of 0.75, which is exactly equal to the opposite divided by the hypotenuse. Same value. Hence, we conclude that the sine of theta is equal to the opposite over hypotenuse. This is part 1 of Introduction to Trigonometry, and here I wanted to take time to show you where the sine actually comes from, which we have now understood that it is a curve. The value of a curve at a certain angle is exactly the same as the opposite of a right angled triangle divided by its hypotenuse. Thank you for watching.